let me tell you what exactly meant by Teradata, right? So Teradata is another RDBMS system. So if you don't know what is an RDBMS, I think most of you might be aware of the definition, like what is an RDBMS. If you don't know, I can tell you this RDBMS stands for Relational Database Management Systems, right? So there are plenty of RDBMS available, like Oracle, SQL Server, alright, and DB2, plenty of database available in market. Even Netezza is also there in market. Netezza, DB2, Oracle, SQL Server, and Sybase. So plenty of databases available in the market. So each database has its own capabilities in terms of loading their data or handling the data. And why Teradata is quite famous for data warehouse. So Teradata is also an RDBMS. So first of all, let me tell you what is RDBMS. So RDBMS is basically a database which can satisfy the core 12 rules, and I think I'm not going into details of the basics of this. Core 12 rules, you know, right? So based on the table definition, the data table should be like this, a row and column should be there, and some kind of relationship between there. There are different rules set up by the scientist called CORD for an RDBMS. Apart from that, it should actually satisfy the ANSI standards. So in terms of SQL is nothing but structured query language. So every database should be talking in terms of structured query language only. That's the reason you see all the SQL is actually following the same kind of rules in terms of writing the select, insert, update, delete, blah blah blah. So all this kind of SQL, the language that we talk to the database, is quite similar, right? In terms of the DB. Okay, so all this kind of SQLs that we are talking to the database is pretty similar. That's why these are called ANSI standards. ANSI means American National Standard Institute. Okay, ANSI standards, all these database should follow the SQL, like including Teradata, Oracle, whatever the database might be. It should follow the standards, right? That's why it is called an RDBMS. So apart from this, before going to the Teradata, in database there are two types of systems, like OLTP and OLAP systems. OLTP is typically like that online transaction processing, which is basically when you go to a bank, right? So you deposit some amount or withdraw some amount or update some address, or you can say update account details, something blah blah blah. Each transaction is carried out at DB level, right? So this is called OLTP transaction systems. On a day-to-day processing, for example, transaction on a day-to-day processing in a banking environment or any transaction basically stands for OLTP systems. What is OLTP systems? Online analytical processing. Analytical is nothing but whenever you have some kind of data available in the database, like a static data, it's not needed to be a dynamic data like OLTP. Every time the data is real-time data. Like for example, if you add some $100 into your account, it will be like 2,500 balance, the latest balance. It should reflect immediately. That is what the real-time data, right? But in online transaction processing, online analytical processing, we don't need the real-time data. Real-time in the sense very updated data. It's like even though it is static data, we'll do some kind of analysis on the data. What kind of analysis we'll do? For example, I'm a managing director of a company, and I wanted to know how my product is actually doing in the market, like what are the sales and what are the margin and how it is actually performing. Let's say product ID, product name, percentage of sales, percentage of profits, marginal benefit, something like that. Some kind of data. Let's say product ID is 1, 2, 3, 4. Product name is, let's say, Apple. I'm talking about iPhone. Let's say percentage of sales this month, last month is 45%. Profit is around 56.8. I'm just giving you a rough figures, okay? Just a marginal amount per piece. Let's say $20. So this is kind of triggers kind of aggregation data in my statistical the OLAP system, the data, which will be used for some kind of analysis. So what kind of analysis I can do as a managing director, or let's say I have a retail company like Walmart. I am the MD or managing director or a manager of a product. Let's say I am the manager of a Apple product, retail business in Walmart. So I wanted to know for the last 5 months how the data is exactly doing. I mean, how the product is exactly doing in the market. So how many products have been sold in the last few months, and how many more I have to order for the inventory, right? Because otherwise, how would I order for more products based on the data, right? So I need kind of some kind of data to do some kind of analysis before taking an actual decision, right? That is what the data warehouse is actually all about, right? The data warehouse is basically a data having the data in such a manner which will be used for analytical processing. Analytical processing in the sense anything, it could be retail or banking or healthcare sector, everything is around data, right? Without data we cannot really decide on what to do. The decision making process is simply depends on the data, how exactly your data is utilized, right? Because as a CEO or a managing director of the company, I wanted to see the net sales or net profits of my product and how it actually degrading from last month to this month sale, or any competition is going between the products, or like I can compare two products. So there are kind of lot of kind of information can be analyzed to have kind of new decision. Like for example, I want to add order more iPhone pieces this month because I have sold all my inventory last month. So I have to order new inventory for this month, and based on the last month availability of this kind of data, I can actually go for the next step, right? That is a simple example in terms of decision making. There could be a lot of other businesses which can do a similar kind of analysis, right? In healthcare, if you talk about healthcare, if I'm taking the patient data, I'm the insurance provider, I can see the data of the patients and see how many claims this patient has made last 1 year, so that I can see how much I'm getting benefit. For example, the patient has taken $1,000 as a premium amount. He paid to the insurance company for let's say $400 per month. So I just want to see how exactly my clients, I mean I'm the insurance provider, right? I can see my patients or members how exactly they are claiming their claim insurance claims. So let's say one member has actually paid $400 as a premium amount per month, and he's actually making approximately $1,000 claims each month. So last 5 months, I can see last 3 months data, he's claimed almost $3,000 just by just paying $400 as a premium amount, correct? So this is a claim. $3,000 is a claim amount. So obviously as an insurance provider, what I will do is I will actually lose the money, right? In case the claim amount is more than the premiums, like a lot more than the premium amount paid, obviously as an insurance provider, I'll be in a loss, right? Because the data can show that, reflect the same thing, because I lost this much, because based on this data, I can go back to the data and see whether the patient has been having any serious health conditions, why is making so many claims every month. So when a patient or member is making more claims each month, that means what it means, the member has a high risk of health, right? He might have some chronic diseases or something like that. That's the reason he's actually climbing more and more every time. So ultimately I'll be end up in loss if I don't increase the premium for this patient, or I can opt some health tips for this to avoid some kind of daily or routine health issues, so that I can actually avoid the more claims, right? Some kind of analysis on the healthcare data. I'm just giving a rough example. This data might not be accurate, but you can relate to the same thing to the real-time environment. So every business needs to have some data to analyze the kind of products or some kind of data to make some kind of decisions in the market. Otherwise, nobody will be surviving this kind of the fast-pacing business, right? So this is about OLAP data. OLAP is typically a data warehouse And Teradata comes into picture here because Teradata has a special architecture in terms of parallel processing. Parallel processing is one of the greatest benefits of Teradata, which will be very faster in terms of data retrieval. Okay, so when you retrieve the data, it's very much faster in terms of Teradata because in terms of data warehouse, if you talk about OLAP, can store a lot of information. The data warehouse will have a huge information. So when you try to pull this much huge information from a Teradata database, it can handle, like within fraction of seconds, it can pull millions of records. That is the speed of Teradata architecture. Because of the unique architecture in Teradata, like parallel processing and the AMP's built-in nature, so the concept of pulling the data is very much efficient in Teradata compared to any other database. Teradata is especially specialized in OLAP processing. Okay, online analytical processing data. That's why Teradata mostly used in all the data warehouse, major data warehouse projects. So data warehouse in, for example, all the major investment banks like UBS, Credit Suisse, a lot of banks are there, right? So they use Teradata, and healthcare like Anthem, Cigna, TTK, and UHG. There are a lot of healthcare businesses there. They run huge kind of data warehouse, and they need Teradata to process this data. Okay, because obviously you have some reporting tools like SAP, BO, Cognos, or SSRS, that is Microsoft again. It's only use SQL Server thing. So SAP, BO, Cognos, SSRS, and then there are plenty of Tableau. There are different reporting tools available in the market, right? So every end of the day, every tool access a database, right? Obviously, the underlying database might be a data warehouse database, that is Teradata. So Teradata can be plugged into any tool, and obviously the backend fires a query when you run from the front end dashboard. It will be running a query in the backend, right? So obviously you'll be linking to the Teradata or something like other database. So that's where the Teradata comes into picture now for the data retrieval from a OLAP system. That OLAP is nothing but a data warehouse. Okay. So any questions so far on the Teradata background or introduction?
How Teradata is different from Netezza, because both are MPP RDBMS, right?
Right. So I think I'm not very much detailed about Netezza, but I think Netezza accesses the data from a file system like Unix files. I mean, it stores the data in the Unix servers, I guess. Anything you wanted to make a change, you have to do through the Unix files, I guess. If I'm not wrong. Because Teradata perspective, I can give you the architectural differences. Because Teradata has a unique architecture in nature, like, if you see these components, the basic architecture I can tell you how the data works, right? Whenever you send a request from an SQL request, right? So whenever you say select star from table name, the first thing comes into picture is your parsing engine. So your parsing will validate the SQL, the syntax. The first thing is your parsing engine, right? Your PG validate the SQL or syntax, any syntax correction, it will take care of all these things. In the PE, PE have like four components again in detail. PG has the session control. It can control how many sessions per PE should be there or what kind of sessions it is actually doing. Like up to 120 sessions, the PE can handle the parsing engine, and the parser will be checking the syntax of the SQL. So you're writing that query called select star from table name where something like that, and you put some syntactically grammatically, it will validate the code saying that the query is not valid, right? So all these things will be done by your parsing engine. The parser will specially look for your SQL request. And optimizer is actually plays an important role, which will optimize the plan. So there is an explain plan in Teradata for each, even in other database software available. So explain plan is nothing but so whenever I write a query, select star from table name. So let's say select star from EMP. So in Teradata you can write cell. You don't need to write select actually. You can write like this or like this as well. Select star from EMP, for example, and I have 100 rows in employee table. Okay, and I put condition like select star from EMP where employee name like starting with M percentage. So I have condition with such condition like this. I want the employee name starting with M from the employee table. So my parsing engine will check for the query first, and it will try to execute a plan. What is the best way to fetch this information from the database, right? So it will try to create an explain plan like how many amps should be used for this operation, and how many what are the where conditions available, and what are the filter conditions. Is there any filter criteria for this, or do you need to search the entire table? All these things will be done by your optimizer. So this optimizer will tell you, like will tell the parsing engine what exactly the best plan to achieve this kind of result. So what is the minimum resources should be used, and how many amps should be used. So AMP is nothing but access module processing unit, which is the heart of Teradata architecture. If you see in the below, after parsing engine, you can see AMP, right? AMP is nothing but access module processing unit, which is like basically does all the kind of data operations like sorting, joining, aggregation. Everything can be done at AMP level. Okay. So when you send the request, select star from table where employee name and all, it will send the query to the optimizer. Optimizer will prepare an explain plan. So this is the plan that I need to execute. So once that is done through BiNet is nothing but a communication mechanism between your parsing engine and AMP, right? So it will actually process the data to the AMP, and all the data operation like the sorting or kind of aggregation, everything will be done at the AMP level. And this is nothing but the virtual disk where the data will be stored, and AMP will pull the data and do the operations and send the data to the BiNet. BiNet will send the data to the parsing engine to the answer set response. Answer set is nothing but your view on the data set. This is nothing but answer set. So parsing engine will does all these things in a fraction of seconds that you don't really able to check on each component how it is exactly doing, but you can see the explain plan to see what kind of operations are being done on the data retrieval part. Okay, so any database parsing engine is a hardcore component, and Teradata, why it is called parallel processing, like all apps works in parallel, and no AMP should be sharing the resources. That is nothing but Teradata shared nothing architecture, and AMPs perform all tasks in parallel. So that's the reason select star from table name where ename is like M. For example, I have 4 AMPs and I wanted to search. I don't have any primary index defined on this. For example, let's say I'll talk about indexes later, because Teradata is mainly roaming around the concept called indexes, because by default primary index will be created by the first column. Let's say I have a ename, I have a primary index on the ename. So whenever I search this condition, if it is a primary index, it is always a single AMP operation. So we'll talk about this indexing concept later, don't worry about that. So I'm just giving an overview like how exactly it operates the data. So whenever you say select star from this one, where ename, we have a primary index on this column. So always primary index will be a single AMP operation. So it will go to the corresponding AMP and it will fetch the data for the corresponding search criteria where employee's name starting with M. Okay, so that is what the optimizer will do based on the primary index. Okay, I have a primary index defined on the ename condition, which is there in the where clause, so I can directly go to the corresponding AMP and fetch the data. This is what the guidance can be divided by your optimizer component in the parsing engine. So this will tell you that okay, we have a primary index condition defined and the column is having the index on that, so we can actually fetch the data from this AMP. So that AMP will be selected for the data and it will fetch the data immediately to the answer set response. So this process is actually driven by completely by the indexes on your AMPs. So how the index is defined is very important in real time, because every table should have kind of proper indexes in Teradata. Unlike in other databases, here index plays a very crucial role, because there is no primary key concept in Teradata. It's like primary index. There is no physical primary key concept in Teradata. It is a primary index basically. Okay. So AMPs will work in parallel and it's a shared nothing architecture. Because of this architecture, what happens is, even though it is like 1 million rows, if you say select star from table where the condition blah blah blah, it will fetch the data within very less time compared to any other databases. If you see Teradata works very faster in terms of retrieval especially. Okay, like unlike in Oracle SQL Server, if you try to run the query for huge number of rows, it will take some time definitely. But in Teradata, it's like very faster compared to those databases. That's why Teradata used mostly in data warehouse processes, because data warehouse will have a lot of information, because we insert the historical data as well, right, in the database. That's where it is a statistical data and it's a static data. It will not change frequently, and it is mainly used for analysis purpose. Correct? So all this kind of analysis will be done at data warehouse layer, not on the OLTP systems. OLTP systems are nothing but typically on a day-to-day transaction basis, like banks and all, which will not directly do on the data warehousing stuff on the OLTP system. Okay? Because it will affect the real-time performance of the system. If you run the queries on the production servers on the main OLTP systems, it will damage the business, right? So we will not touch the OLTP systems for data warehouse. It is a separate entity again. OLAP is like a pure data warehouse system where we can have the data separated for the historical data or not, and we'll do the analysis separately. Okay, clear on this architecture? Any doubts?
Teradata will, if suppose employee table is there, then the data in employee table will be stored in different AMPs, right? Not in one AMP.
Yes, yes. So yeah, even though it is spread across different tables, based on the primary index, the distribution will happen normally. So when you define the primary index and the employee name, based on the employee name, all the data will be distributed equally on the all AMPs. Every AMP will be used, not like single AMP. Only the operation, like the retrieval, will be single AMP operation, not the data storage. Okay, don't confuse with that. Data storage will be in every AMP.
Okay, and
The
each
kind
AMP
of
will be
accessing the data. Yeah. Tell me.
So if suppose the primary index is M here in your query, and data
Okay.
storage is names which are starting with M will be finally stored in one AMP only based on the primary index. Or else even if it is starting with M, then it can be distributed to different AMPs.
Yeah, even though it is distributed in different AMPs, so what happens is there is a concept called hashing algorithm in Teradata. So all the data will be stored based on the hash values. So hash values, is basically same for same kind of data. Like for example, if the name is like, let's say Michael, all the Michaels will be stored in one AMP, because you have the hash index value for all the Michael will be same, the hash row values. So in Teradata, all the values will be stored based on the hashing algorithm. Hashing algorithm is nothing but generates the alphanumeric value for each column. So obviously if the name is same, it will just generate the same hash value. But if you say primary index on the corresponding values, what it will try to do is, it will try to distribute the data evenly based on the primary index. It will not store all the M amps into same thing. But what happens is, when you say where ename like M, it will try to see whether the index is defined on the primary index, and it will try to see what are the hash values defined for the values starting with M, and all these values will be looped into a hash bucket. So hash bucket is nothing but your AMP. AMP is nothing but combination of hash bucket, hash row, and hash AMP. There are three components in Teradata. That is much detailed level of architecture. I will tell you about that. How the data exactly stored in the AMP based on the hash bucket, hash row, and hash map. So all these hash maps, hash AMP and hash map will store the same kind of information in one single AMP. So that what happens is, whenever you use the primary index with the condition, whenever you store the condition with the same thing, right, with the primary index, it will directly go with the corresponding single AMP operation. Okay, so I can tell you the detail level architecture in the coming classes. Okay, how the data exactly stored in terms of amps. Alright, but whenever you use a primary index in the wake clause, it is a single AMP operation, and when you use a secondary index, it will be a 2 AMP operation. So I can directly tell you how exactly it is a single AMP or multi-AMP operation in the coming classes. So this is how the distribution normally happens whenever using the unique primary index. There are two different primary indexes, unique and non-unique primary indexes. Unique primary index will store the data like this evenly in all AMPs. Okay, let's say there are some kind of 9 rows, all 2 and one additional row in this AMP. 1, 2, 3, 4. There are 4 AMPs, and we have all the data distributed in all AMPs. Okay, based on the unique primary index. Unique primary index means there are no duplicates in the primary index. But when you say NUPA, there are duplicates available in NUPA. In UPA, there are no duplicates allowed. So all the data is distributed equally because it's like more uniformly distributed whenever you use primary index, unique primary index. Whereas when you say non-unique primary index, which can be applied on the non-unique column, like here, the customer number, all 1s into 1 amp and all 2s into 1 amp and all 3 into 1 amp. 1 amp is left idle. So this is called skewed. Skewed in the sense the amp is not utilized properly by the Teradata. So this kind of thing happening in the kind of non-unique primary index. So when you use NUPA, what happens is the data is not distributed across the amps. It might be possible that some kind of amps will not be used at all, because if you see here, even though it is evenly distributed across all the amps, 1 amp is completely left, free. So this is not a problem in Teradata. This is a kind of scenario happens in terms of NUPA cases. So this is also okay, acceptable, because until unless there is no much skewness in the sense whenever an amp is actually free or idle, is not actually handling any kind of data, then that kind of scenario is called skewed. When more amps are skewed, your performance of the query is poor. That's why you have to choose at least one UPA column for a table in most of the cases. Okay, even though if you use NUPA is also fine, because it's a primary index ultimately, right? So whenever you say primary index, it is always a single AMP operation. In the where condition if you use, not on the directly select star from table. Okay, whenever you say in the where condition or a join condition, you use the unique primary index, obviously it will be single AMP operation. So that is the reason Teradata by default creates a primary index, non-unique primary index. If you create a table, when you create a table without any mentioning the primary index, by default the first column will be chosen as the primary index. Okay, so we'll talk about the indexing and how exactly it is actually allocated to the data and all. I'll just show in the tool directly, the SQL tool, how exactly the distribution happening. This is about secondary index. We'll talk about this in detail, how the data is distributed using the secondary index. Because if you understand this architecture, you can actually clear the certification. The first exam is based on the architecture and all the basics, right? In real time, we don't need to worry about these concepts, because ultimately the backend is the same thing, right? Whatever you running the queries, they're based on the same concept only. If you understand these concepts well, you'll be able to relate to the main queries, okay? How exactly your data is queued, and especially in terms of performance tuning, because you're running out of spool out issues. In Teradata, if you're not using the properly joins on your indexes, you'll be running out of memory. That is nothing but spool out issues. Spool out in the sense, your query, there will be some temporary space allowed for your query. Whenever you're exceeding that space, you'll be running the spool out issues. It will say that there are no more spool space available on your user ID. So if your poor queries are like without any join condition or poor conditioning or poor indexing system, then definitely it will spool out. So in real time scenarios, most of the times the spool out issues will come, or some kind of the skewness happens, or we have to rectify those things in terms of performance. Okay, this is about a high level architecture of Teradata, how the data is actually processed in parallel way, and based on the amps, number of amps available, how the parsing engine will work. Okay, right? So this is a kind of architecture, and this is unique compared to any other databases. Any questions here on the architecture part, guys? All clear? Now, coming to the course content, this is pretty much crispy sessions, about 20 hours. Okay, we'll be doing an hourly basis on a daily basis on each hour. Okay, so we'll be covering most of the concepts in Teradata as per the course content. If you see here, what is the Teradata architecture, parsing engine, SMP and MPP architecture, how to install the Teradata database. We'll be providing you the software and the details to install on your laptop so that you can practice on the SQL and the scripts. This is about the introduction, and then coming to the space management and all, we'll talk about what is spool space, permanent space, temp space, and all the spaces, and on the components as well. How the type of logs will be available in Teradata, and Teradata data distribution using the primary index, secondary index, what is the hashing algorithm, hash map and hash bucket, unique secondary index, non-unique secondary index. We'll talk about the indexing and the data distribution. Okay. Now, and the next one is, like, other than the basic primary and secondary, we have partition primary, multi-level PPI, join index, hash index, explain plan, what is explain plan, how to read it, and main keywords in explain plan, how to relate to that. Okay, all this stuff. And then the important concept called color statistics, which is very important. Color statistics, product join, what is inner route, left outer join, right outer join. It's kind of a sequence. And what is high, low, and no confidence in the explained plan. I'll tell you about these things. And performance tuning is part of this color stats only. We'll talk about how to tune the queries, in terms of better efficiency. And these are the SQL, like we'll talk about the SQL, right? Data type, string function, format, cast, date, coalesce, group, and aggregate, qualify, row number, partition by. So these are very important, qualify and row number and rank. Every interview they will ask you about this. Okay, most of the guys don't know the difference between these three exactly. There are a lot of confusion always around these three concepts. We clear out that by taking a beautiful example, so that you will definitely not forget about the differences between these. Very important. And once we're done with the SQL, we'll talk about the utilities, which is the specialty about Teradata, because any tool is actually having a SQL, but no tools are giving these kind of utilities like Teradata, like BTEC batch Teradata query. BTEC stands for fast export, fast load, mload, TPT. There are different tools for different purposes, to load the data, to pull the data, to update the data, something like this. We have a set of kind of utilities available in Teradata. And finally, we'll talk about best practices in Teradata development and real-time examples and with case studies. Okay, this is about the course content. Any questions on this course content? So we'll be providing you the software. We need at least i3 processor on your machine, i3, i5 or i7, because Pentium will not work on Teradata. So hope you have all the latest laptops with you, with the latest processor at least, because VMware won't support otherwise, because we'll be installing the server directly on the VMware, the Linux server. Teradata is on the Linux based, so we'll be installing the database on the Linux server and client as well. Client is on the Windows machine, that is on your local desktop. Okay, so once we install those two, we'll be ready to. It's a very simple installation, so it will not take much time. Half an hour is fine to install the software. So once you register for the course, probably will be giving you the software details and the installation guidelines to install on your local laptops, and we'll assist you in case you're not able to do that on your own. Okay. So that's it from my end.